with focus on the use of meteo stations. Let us welcome Daniel onto the stage.
Thanks a lot. So let me then move on what we are doing as Vereinigter Hagel under the brand name Meteosol to deal with the issues we have already learned a lot about in the previous speeches. We can't control climate, but we can face this challenge with a significant advantage by using precise and especially reliable weather data. And that's actually the topic of my presentation, the role of weather data in mitigating and reducing weather-related risk. So farmers are more affected by the impact of climate change and changing climate conditions than any other industry. As we have already heard, in the context of climate change and climate risk, the scientific perspective is clear. We are witnessing an increase in extreme weather events. Our world is getting warmer. Weather is becoming more destructive, and yes, human activities are the main cause of these changes. Understanding and, more importantly, managing these risks, these changes, is crucial not only for policymakers or the industry, but also for you in practical terms. In practical terms, the cornerstone of your needs is the availability of accurate, of reliable weather data. And especially in this area, we've seen a significant approach, significant progress in recent years. Allow me to use a meteorological example. Today's 5-day forecast is as accurate as the 1-day weather report in 1980. With reliable weather data, we can make more informed decisions than ever before. And yes, let me emphasize this up front, we can actively reduce weather-related risks. So the central question we have asked as an insurer and a weather service provider, and will answer today finally around this issue: how can we leverage weather data to minimize weather-related risks in agriculture? Certainly, US farmers are, sorry, that was the wrong slide, that's the right one. So certainly US farmers are undoubtedly most familiar with the challenges and risks to your location. However, allow me to provide an initial assessment when we talk about weather-related risks. I had the privilege of conducting a study among German farmers in the last year focusing on weather risk and their management, and the analysis aimed to identify various weather-related risks and shed light on potential responses. So when discussing weather risk in the face of agricultural challenges, the spotlight first falls on yield risk. As a crop insurer and weather service provider, we see a change, and yes, we can confirm extreme weather events are increasing across Europe, both in frequency and intensity. So in the agricultural sector, the risk of drought, heavy rainfall, hail, storms, and are particularly pressing, and the consequences of this yield risk are well known: reductions in yield and also quality deficits. In the ongoing discussion about agriculture, the term regulation is frequently mentioned, and the rising regulations, environmental risk, and the new European agricultural policy broadly fall under the category of legal risk. Legal risks are crucial, especially concerning weather-related factors, notably in the realm of pest control measures or general documentation. And the third category of weather-related risks includes the so-called planning risk. Risk of planning refers to potential discrepancies between planned objective and actual results. Planning risks are especially significant as agricultural decisions are heavily influenced by various weather variables, for example in crop planning or daily operation. We all know we can't change the weather as an influencing factor, but we can leverage weather data to recognize and identify risk using them for decision making. We can document weather data and use it as both documentation and legal evidence. However, before delving into the opportunities, I would like to discuss the main challenges with you we are facing right now, and especially in agriculture. When we discuss the need of reliable weather data, we must acknowledge that the quality of freely available weather information is often insufficient. We observe a decline in scientific weather stations, and discussions with my local colleagues emphasize that the reliability, meaning the quality of available weather data has, let's say, rate for improvement. Another issue is the often delayed data transmission and often too long measurement ranges, especially with regard to weather stations. This poses a challenge as weather stations can also be used for forecasts or warning systems. In addition, we obtain incorrect values, especially in the data collection from weather station. Incorrect measurements can lead to misinterpretations and accordingly, in worst case, incorrect decisions. So what we see is a lack of reliable measurements in a small scale. This means high-resoluted weather data. And the question now is, what is the key to obtaining small-scale, high-resolution weather data? And it's local measurement. Local measurements are essential to understand local weather conditions. And especially for us in agriculture, it's crucial to obtain not only reliable, but also local, small-scale weather data. It helps us to know if it rained 3 kilometers away in the field, if frost is expected in valleys or depressions, or if wind conditions allow our field work. At last, the goal is to reduce the previously mentioned weather-related risk, yield, legal, and planning risk, and this can only be achieved by farmers like you and us as a weather service provider accessing small-scale, high-resolution weather data. And precisely for that, how small-scale such weather events can be, I have brought 3 examples to illustrate. So when we talk about weather-related risks, we can't avoid talking about meteorology. The example shown here illustrates how much the distribution can change in a small area, in particular with precipitation. We talked about it earlier. And perhaps you recall the planning risk. So in Germany, we have many farmers who use our precipitation data to plan their field work, especially when fields are not near the operational center. A completely different scenario can unfold on site. And as we all know, especially when we talk about precipitation, we are discussing one of the most crucial parameters in agriculture. What we often see are small-scale differences in topography. Frost protection, especially for specialty crops, is certainly a key aspect here. So let's take the example from the central German region. As you can see it here on the slide, we observe communities that are only a few kilometers apart and still can experience temperature differences of almost 10 degrees between our weather stations. Now you might say, as a farmer, I'm already aware of these differences from practical experience. That's true, but for weather models, weather warnings, and above all, a reliable weather forecast, such differences are crucial. And no, these differences are not always just due to the topography. They often also have something to do with different weather conditions. And our models, our weather models, can identify such differences so they can learn and adapt to different weather conditions. For example, imagine a frost warning that is accurate enough to recognize the small-scale temperature fluctuations in special weather conditions like you can see it on the slide. And the last example that I bring to you is indeed small-scale and located just a few hundred meters away from our weather station. And yes, a tornado, as occurred here, certainly fits into the category or into the Premier League of extreme weather events. Yet, even in such a case, a storm warning can be predicted. We can predict this, for example, by measuring wind parameters in a small room. You will then see the wind directions turning in corresponding opposite direction, and that is also what we were able to reproduce here, even if the weather station didn't measure the heart of the tornado. So what have we seen? What is the key insight? Weather is small scale, but what do we need to access local weather data? And there, a fundamental aspect remains on local on-site measurement. So on the left, you see an image of a weather station. It's the local weather station that assists us in understanding the weather on-site, placing small-scale data points, and consequently producing reliable long-term weather data. A weather station is the key to essential measurements, a dependable data history, accurate current data, and above all, reliable weather forecasts. Allow me to delve into the weather forecast in more detail later. For now, it should be noted that the data from a weather station, if measured reliably, contribute to existing forecast models and helps to recognize local climate differences. Those who precisely record the data on site also receive precise documentation. So that's another advantage, particularly when we revisit the purpose of documentation or consider legal risk. But also when we think of surf weather events, the accuracy of weather forecasts and warnings significantly improve when weather stations operators share their data and refine them through a weather station service provider, through forecast evaluation tools, or if necessary, weather assessments. But to be on the safe side, there is something to consider in the whole process. To make effective use of data from weather stations, there are certain requirements which must be met. How do these requirements for operating your own weather station look like? And here the keyword is comparability. To make meaningful use of the data, it is crucial that we ensure comparability of the collected measurements, and this simply means that weather stations must operate according to standardized rules. And here the gold standard is based on the criteria set by the World Meteorological Organization, and you can see it quite clearly in the photo. Primarily, it is important that the data is collected in an open field. The wind is measured at a specified height of 10 meters, and the location in general should reflect the local climate conditions. So these are the so-called site criteria for which we also provide an initial consultation to our customers, a location assessment. And okay, now you might say, but I want to know what is happening in the middle of the field in my plant population and not in an open field, as you can see it here on the photo. And yes, it can be useful in individual cases to measure specific agricultural parameters in the middle of the field. And for this purpose, we at Meteosol offer, together with Jan, Mr. Barani, a separate unit. We call ours the Meteo AG. And the sensor of the Meteo AG can be placed into the plant population so that we can obtain measurement results directly on the plant. But most of the common parameters, such as temperature, wind speed, or precipitation, can only provide comprehensive added value when data comparability is ensured. And understanding this network concept, the concept of comparability, is fundamentally crucial to not only collect small scale, but above all, reliable weather information. So these site criteria are actually not only fundamental for the farmer, a real benefit emerges for all of us when weather stations fill our models, our climate models, according to standardized measurements. And this not only makes the data more reliable, but also more localized. And in the end, this is the significant added value which a weather station, as you can see it here, provides. So what have we learned? In agriculture, reliable and localized weather data is crucial. A weather station on site whose measured values have been collecting using standardized comparable methods is the best way to achieve this goal. And to be honest, no matter if you operate a weather station for 100,000 euros or for 2,000 euros, measurement errors will occur. A weather station is technical hardware exposed to the elements 365 days a year, and it's entirely normal that for the rain sensor to become blocked, or for example by leaves, or even the temperature sensor at the ground level, which gets overgrown by plants. Even so, it is crucial to detect and correct such measurement errors early, and consequently an ongoing monitoring of the measurements and a quick error correction becomes even more important. So a question: what classic issue regularly overwhelms our rain gauge, our rain sensor? It's bird dropping, bird shit. So maintenance of a weather station doesn't require much effort. Even with bird droppings, an ordinary cloth helps. But the maintenance issues we have, I can count them on 2 fingers. The maintenance issues we have are crucial: riping, the rain gauge, bird droppings, or leaf and autumn. and keeping the ground level temperature sensor free from vegetation. This, for example, is crucial since the sensor is primarily used for frost warnings, especially in spring. So you can see operating a weather station doesn't require much effort. However, the maintenance issues we have are all the more important. So I know it's the wrong map, but I'm confident that there will be a similar one soon filled with weather stations. And we now have our weather station in operation, having localized weather data and an extensive measurement network. So what are the use cases? What can we actually do with all this data? Example number 1, precipitation. Here you see the annual totals. We can historically trace more precisely how much it rained in different regions. And yes, we can also track extreme weather events like nearly 50 liters in an hour. We can also receive much more precise surf warnings, weather warnings. On the left side, you see the warnings issued before the surf weather event, and on the 2 radar images, the following confirmation. And here's one more example of multiple thunderstorm cells. You don't have to be a meteorologist to recognize the direction of movement in advance. The lines circled on right represent the expected direction of movement, so nobody needs to be surprised in this case. And finally, it's the improved forecast. We talked about it. The improved forecasts that simplify our daily task, particularly in agriculture. So on the right, we observe 2 forecast models illustrating how we can generate significantly more accurate weather forecast with the aid of a climate information by our weather station. And yeah, the upper model, which you see here, includes our weather station data, and you can see that the forecast quality improved significantly. The measured values are much more closer to the previously predicted temperature values. So our weather station helped to make more accurate local forecasts depending on certain weather phenomena. So we remember the previous example of temperature differences and the example of frost warnings. We can see nowadays it is possible to feed existing weather models with weather data from our weather stations according to improve the local forecast quality, and to do this, a data history of our weather station of at least 18 months and a mostly complete recording period is required. Then these models leverage the data history of our weather stations and adjust calculated values for the future based on the specified location. So a brief review at this point. We have our weather station as a core element. The station helps us to record local weather data. It supports us with documentation and daily decision making, and ultimately provides a databases for the existing forecast models to further improve weather forecasts at our location. So we have a self-learning system here. We have reliable weather data at a historical level. We can see the current weather situation and can make decisions based on an improved forecast. So an easy saying to remember: who wants to forecast locally also has to measure locally. Nowadays, we are able to achieve this added value with affordable weather stations. And as we have seen, it is important that we can stick to certain standards and that the provider of the weather station is a company with expertise in the field of meteorology. And we talked about the hardware side with Yambarani. Every weather station, every piece of hardware comes with software. We don't just share our weather updates through computers. We also have our own app, like think of having the weather right at your fingertips. And to give you an impression, I've brought along a few screenshots from our online tool for you. Like on the left, you can see the measuring network of the German Weather Service, upon which we overlay our weather data, our weather models. And while our weather station enables us to provide leading forecasts, we often encounter uncertain weather conditions, especially in summer. For example, for precipitation in particular, it's worth checking our multi-model. And here we present the leading forecast models in one view, allowing you to see whether all models align or if there are significant deviations indicating greater uncertainties in prediction. As mentioned earlier, we emphasized the significance of local data. We distinguished ourselves by calculating weather data on a small scale down to the field. And finally, on the right side, you'll discover our radar application. So our aim is to produce high-resolution images using weather data, completing the puzzle of detailed and reliable weather information beyond the capabilities of traditional weather stations. So let's return to the initial question, the question of weather-related risks and how these risks can be reduced with the help of local weather data. We have talked about yield risk, legal risk, and planning risk, and I think there's no question that when it comes to yield risk, our crops are still largely dependent on Mother Nature, on the local weather condition. Improved forecasting, for example, using the ground level temperature sensor in spring, which helps to calculate frost warning, or the deployment of hail nets in fruit growing enables us to react to certain weather conditions. Local data collection helps us to recognize and assess existing risks more accurately. And for example, in the insurance industry, this data also helps us to design tariffs in such a way that the actual risk is covered, as Mr. Gerko told us. Evidence from weather stations is playing an increasingly important role in terms of legal risk. Standardized measurements not only serve as proof, but also for documentation. However, the most important, the greatest added value is the improved basis for decision making. So you remember the planning risk here, in particularly reliable data collection and improved weather forecasts provide a more reliable basis for decision making and therefore increase planning security, which in turn reduces costs by making the right decision possible. And this is finally the result. With the help of small-scale weather data, such as that collected by a weather station, we can now better identify risk, we can document weather conditions and thus understand them. And above all, weather data can help us to improve our day-to-day work, especially through small-scale data and precise forecasts. So if we as a weather service provider do our job right, we deliver what matters in agriculture, reliable and localized weather data. And a key factor in achieving this is the operation of a weather station, which assists us in gathering this local information. And as someone who's not only engaged in theory, but also in practical terms, you've seen the map, we operate over 1,000 weather stations in Germany and regularly receive feedback from our customers. These responses align with what literature and meteorology promise. A weather station can enhance efficiency, establish a reliable basis for decision making, and actively contribute to reducing risk in agriculture. Thank you very much.
Thank you, Daniel. Dāmas un kungi, vai ir kāds jautājums Danielam droši?
Any questions to Danielle? If there will be no questions,
Last question from my side. We're turning back to the presentation by Toms Bricis. He was asked about the combination of local weather stations and, well, let's call them national level weather stations. And his answer was that the weak point right now is the quality of data gathered by these local weather stations, not because they don't work good, but because of where they are set up and some of the risks around them. You mentioned tall grass and them being dirty. Maybe some tips and tricks for farmers here who have their local weather stations, how to keep them well maintained, how to keep this data accurate.
Yeah, it's all about the partner. You need a partner or a company which runs the weather station, which uses the data for like forecast models. And that's basically what we do in Germany. And I think stay in contact with Vereinigte Hagel and Latraps. We are also entering the market here, and just keep in touch with us. And so we are going to build up a measurement network here, hopefully together with you. Yeah.
Ļoti labi ziņas. Dāmas un kungi, liels paldies Danielam Sticheram. Thank you, Daniel.
Thank you.